Hello everyone, welcome to my channel. So today we are going to do Leetcode weekly second question, testing prime factors of product of array. So let us first read this question, then about constraints, then write down the example, and then finally the coding part for the same. So now let us go ahead for reading this question. But before that, let me introduce you with Newton School coding contest. The way you are doing Leetcode bi-weekly, weekly challenges, you can also try it with Newton School coding contest. So you can figure out for every detail in the link, which is in the description below. And yeah, all the top performers would be getting some exciting prizes. For that also, you can figure out in the link itself. And yeah, so you can head over and register for the same. So now let us go ahead for reading this question and then finally doing the same. 1 minute. Okay, so here, given an array of positive integers num, return the number of distinct prime factors in the product of the element of num. A number greater than 1 is called prime if it is divisible by only 1 in itself, and integer value 1 is a factor of another value 2 if value 2 by value 1 is an integer. So now here factor definition and what is the prime number, that all is given to us. So now here, given an array of positive integer nums, return the number of distinct prime factors in the product of element of num. So basically here we are given with the array which is there. Now return the number of distinct prime factor in the product of the element of num. But the thing is that actually we are not required to do product of nums which is given here. Actually it is a medium level question. So surely there would be some trick. So that's the thing I want to convey you. So here this nums which is being given to us. So here we don't need to do product of all the numbers, means we don't need to come up with this aggregate. We just directly need to do prime factorization of each number which is being given to us. And that's what they want to convey us, that we need to do product of these numbers and then get the product and do the prime factorization. Now here it's a simple rule. Now first let us check for the constraint, then I'll go ahead. So here I don't want to show the solution first. So here we are given with 10 raised to the power 4 as the nums dot length. Means at max there would be 10 raised to the power 4 elements. And then nums of I can go up to 1000. But when it goes up to 10 raised to the power 3 and there are up to 10 raised to the power 4 numbers, that means that there could be TLE6, not TLE actually, but uh, means when it is like this, means 10 raised to the power 3 and 10 raised to the power 4, there could be runtime error. So that's the scene here. So now let us go ahead with the coding part for the same. So the thing is that first we are required to code for the portion of that finding prime factors. And then after that, means that would be one auxiliary function which we will be writing. And the main portion of this particular would be that we are required to, is actually the main portion is this prime factorization part only. But after, we will be directly passing whatever number is there in this particular array and then getting the prime factor for the same. And then as we require only distinct prime factors, right? So we will be here using unordered set so that it eradicates all the duplicates and give us the distinct prime factors. So that's the thing here. Now let us go wait for the coding part for the same. Okay, so here, now here, what I have done is I have taken another set. I could have taken int also because unordered set by itself. Because the thing is that at max it will be going. See, here they have already mentioned that at max it will be 10 raised to power 3. So that's why I can take it as integer value also. Earlier, actually, what I was doing was I was directly taking the product of all this nums which is being given to us. So because of that, I was thinking that I require this, but it actually don't require this. So that's why now we will be calling this prime factorization function, in which we are passing each number which is there in our input, which is there. And this count is basically this particular unordered set, which we will be storing all the distinct prime factors. And then at the end, we are required to return the size of this particular unordered set. Now, here we are doing the prime factorization. So first we are checking that if there is 2, then we will be inserting the 2 here and dividing it by 2 so that we get the next number which is there. And then here we are starting from the 3 because 2 and 3 are the prime factors, and after that all others are there. So that's why starting from 3. And then we are checking, means we are going up till that square root of n only, and then adding up 2 to the same for figuring out for the prime factor. And then while our n modulo I means this 3 or whatever, after adding the 3, that 5 would be there, that 7 would be there, and then that 9 would be there. So whatever would be there, if it is equal to 0, then we will be inserting that I and then dividing that by I. And then after doing all these portions, then we are required to check that if our n is greater than 2. Means after dividing so much with the numbers which are there, if still n is greater than 2, then we will be inserting that particular into our count. Means our count unordered set which is there. So this is what all we are required to do in this question. Now comes the part about the time complexity and the space complexity. So here it is order of n. Right. But here, when we are doing this prime factorization, whatever standard time complexity is there for prime factorization, so that is the time complexity here for the same. So here it is square root of n, and then while n modulo I means basically here time complexity is directly square root of n. Actually, I'm not much sure about the time complexity of this particular portion of the code, but whatever the time standard time complexity is there for figuring out for the prime factors, that is there. So now at the end, the time complexity would be order of n into whatever time complexity is there for prime factorization. So that would be there. And why into multiplication? Because of the fact here it is inside the loop. And everything which would be done, that would have been done inside this only. And now the comes for the space complexity. So space complexity for the sameness, like here we are just using this unordered set. So that's why it's order of n. So yeah, this was all for this particular question. If you have any doubt, you could comment it down, and also just let me know that what would be time complexity for the prime factorization. Let us be activity for you as well. Yeah, I will be also figuring out for the same because I have just forgotten, and even from this also, presently I'm not sure that what I am thinking is true or not, because it's about the square root of n and also this while n is there. So it's all about n log n something like that, but I'm not sure about the same. So that's why I want to be sure, then only I can take. So yeah, this was all for this particular question. If you have any doubt, you will comment that down. And yeah, please do like and subscribe to my channel. So yeah, this was all. Thank you.